I wanted to learn Civil 3D, because it is probably the hardest program Autodesk makes, and also because I enjoyed working for the few surveyors I have through the years. Hiking is one of my favorite pastimes. I have hiked in this area a few times, it is kinda stunning. New Mexico 68 connects Taos to the country through the Española Valley. The stretch of road is mostly straight, not very flat. This stretch is around 5.5 miles long. As the water flow lines show, there are about 100 arroyos cut into the terrain draining from the mountains to the southeast, then into the Rio Grande Rift along this stretch of New Mexico 68. Existing dirt roads access houses, others access recreational areas. The climb from the Española Valley is steep. This is also where the Rio Grande Rift starts widening as it flows into the valley. Here is the bridge crossing accessed from Pilar, which is a popular destination for rafting, fishing, hiking, camping, soaking in the nearby hot springs and other surprises. This is an ancient trail into and out of the valley. So I used this huge swatch of acreage as my area of interest, and the limits of features. It includes most of the climb in 68 to the west, and bounds at Rancho de Taos at the east. A 2-point circle drove the rest of the boundary. Then using the existing roads as a base, laid out a perimeter road system. I leveled the road surfaces, but kept the elevation changes in the natural topography. It made some interesting road cuts and fills. This is a section. It is center line on the new road, and also slicing through the surface. This is the alignment, path through the new topography, which will be the new road surface for New Mexico 68, in this new city. The gray grid lines are 100 foot. The red line is showing the existing surface. The green line is where I broke the surface of the road. The sideways text shows my grade breaks of the new road. The percentage is the pitch of the new road surface. The lighter blue line shows the new road surface's top center line. The new road surface's center line is depicted with the double triangle in the middle in yellow. The profiled representations will be what the program uses to build the three-dimensional road surface. The outside edge of the road cuts were used as reference for a new three-dimensional topo map, outside the boundary topo areas. The outer edge of the inner sidewalks were used for a new topo reference inside the city boundary. This is the topo inside the city boundary that was generated using the sidewalk lines from the new road surrounding the new city. Keeping the center line of the new road surface, and using the existing roads as a guide, I laid out the rest of the roads for the city. I took care to stem out access for the businesses from two ends. The roads that were named, Arroyo del Alamo, Los Alamitos, and Tierra Blanca were relaid out with their same names. The streets running horizontally are all named after Stephen King novels. The streets running vertically are all named after Blue Oyster Cult songs. The streets south of New Mexico 68 are all named after dead musical performers. I used 300-foot radius circles at the major intersections, and 100 and radius circles at the minor intersections. I use those radius circles from the new road center line layout, in the profile section, for a reference, shown here as the vertical green lines. The circles in this profile I use for a reference to keep the center of the new intersections level. Then alignments for every street were laid out on the new road center lines. Then profile sections of every street and road were laid out. The intersections were then cross-referenced in the profiles to ensure the new topo was balanced between the arms of the feeder roads and the intersection center. Eventually, there was over 400 corridor segments and intersections. I made VBA and Lisp routines to strip out unneeded entities, for my purposes, from the exported models. I dressed every intersection with curb cuts, lane striping, traffic lights or stop signs as needed, lighting, crossing buttons on the traffic poles, walk signals, signage, everything you see here basically I produced from scratch. I created every sign needed, again from scratch, to maintain a standard I wanted to keep for the city. like black backgrounds and softer lettering in the signage. I didn't change any universal standard, just the look of them. Now that all the entities are placed, it is time for the topo. Using the inner sidewalk edge lined with a 3D line along every face as a reference, the new topo is contrived. The topo is shown here with 2-foot topography lines. It is showing a 90-foot drop from the northwest corner to the southeast corner. I used AutoLisp to place trees, bushes, and plants. Here represented by 3 3D faces. The plants near the road are purposely shorter. Depending on the zone, the routines were set up to sort type, size, as well as the rotation, for a more random look. In the topo outside the city boundaries I used a slope analysis. Any 3D face that was over a certain percentage of pitch was separated. Along the roads also were separated and treated with a different scheme through the Lisp routines I wrote. The trees were added according to the standard set by the Lisp routines. Then the models were mapped and textured. Here is the difference to the road edge treatments. In real life they could never build a dam where I have put one. The rock isn't stable enough to dig canyonized style roads with such steep road cuts like I am showing. But this is a 3-dimensional model and I am not an engineer. I laid the center line for the new dam using existing road features as a reference. This is a typical road section around the perimeter of the city. I made the cut and fill at the end steeper for the dam and the canyon-like road cuts. This is the profile. In blue showing 0% slope is the center line of the new road surface at the top of the dam, sitting at an elevation of 6,700 feet. On the northern axis the grade is 5.4%, and on the southerly end, a little greater than 9.4%. The dam is about 3,000 feet long. The red solid line dipping down shows the ground surface. The red dashed line depicts the water level at 60 feet below the new road center line or 6,640 feet above sea level. About 600 feet deep here at this section. The actual bottom edge of the concrete on the side holding the water is going to decrease that figure. Using the model itself I find it is at 6,051 feet or 589 feet of water. In the model I added intakes with decorative domes. I also added a deck or lip for swimming with sidewalk and stair access to locker room areas. In the front I added a spillway. Here is a closer look of the intakes. When the elements are combined, the outer topo, water, a car to help with visual scaling, and some animation, you get a more elaborate depth to the model. At the left near the top of the water feeder domes visually, you can see the fill in the road at the intersection of this new road, New Mexico 570, and Sun Jester West, in the cluster of overhanging lights. This method is not very quick about finding holes and other problems in the model. This 52-second 3,000-foot rendering took about 8 hours. Speaking of time, this entire model, including the learning curve, took about 4 years, on and off. No one program would load the entire model to help find holes and problems, so I used a gaming engine. I dressed objects to use between all the programs, cars, buildings, houses, and so on, then placed them to help with depth. When it was completely loaded into the game engine I could drive around looking for holes and other flaws. I could finally visualize the entire model. Never having used a joystick or played computer-based games, I ended up like this a lot. I took it in parts as needed into a renderer and used their native content along with mine and others to make scenes for a movie idea I had. I made my own characters to use in all my scenes. Outsiders who end up in the city are here to die at the hands of my main characters. Mostly in strange comical ways. The actors themselves have backstories, to help give a dimensional effect here also. It is a continuation of a short story and teleplay written by Stephen King. I call mine A Hell of a Band Part 3, Taos Junction, The Old Gods Return. Part 2 only exists as a story between the characters throughout the movie. According to the lore, anyone who committed suicide is a public servant. Other inhabitants aren't mandated to anything, some participate anyway. Anyway, from Civil 3D, to Max, to DAZ, to Unreal, using C, Python, Visual Basic, VBA, Lisp as well as Photoshop to get there. It's been a long road. I learned quite a bit more than I set out to.